Hey guys, in today's video I'll be going over an introduction to what linear and differential equations are. So the first question I'll be answering is, what is a differential equation? Then after we understand what is a differential equation, I'll just go over some pretty basic examples of first order differential equations that, it's just a good recap from Calc 1 and Calc 2. And then lastly, I'll go over something pretty fun that is kind of a motivation for why you want numerical approximation methods. Okay, so first off, what is a differential equation? So a differential equation is just any equation in which you have the equation being a function of a derivative. So this is an example of a differential equation. We know it's like a really simple differential equation, and we get y as a function of t is just equal to some constant. So other examples of differential equations could be x y prime plus 2 is equal to 0, or any general function that has this dependence of a derivative right here. Okay, so now that we defined what a differential equation is, I'll just go over a few relatively simple examples that should be remembered from Calc 1 or Calc 2. So the first example we already did was right here, where we have y prime, which I'll just say is dy with respect to time, for instance, is equal to 0. So for this one, we can just integrate both sides. We know the integral of 0 is equal to a constant, so then we have y as a function of t is just equal to some constant. Okay, so now following this theme, why don't we just do this one? So we have x dy over dx plus 2 is equal to 0. So for this one, I would do a separation of variables again. So I'd try to get my dy on one side and my x's on the other side, kind of just like basic algebra 2. So we'll subtract 2 from each side and then divide by x. So we have dy over dx is equal to minus 2 over x. We then multiply our dx to the other side. So we have dy equals negative 2 over x dx, and we can see here that we can simply integrate both sides. So the integral of 1 times dy is just going to be equal to y, and then we have the integral of negative 2 over x. So that's just going to be negative 2 natural log of x, and then since this is an indefinite integral, we always add a plus c. So this plus c is actually really important for future differential equations, and it's always going to be found given your initial condition. Okay, so lastly, I'd like to go over an example problem that kind of shows why we need numerical approximation methods. So let's consider the function 2 dy over dt plus ty equals 2. So for this equation, it's in the form y prime plus p of t times y equals some constant. And this is like a well-known form of first order differential equations, which we saw via the integrating factor method. So I'll be going over this in a future video, but just believe me right now. And we'll use the integrating factor method being e to the t squared all over 4. Okay, so if we multiply this on both sides, we get e to the t squared over 4 times y prime plus ty all over 2 equals e to the t squared over 4 times 1. Okay, so right here, I just divided this 2 on each side. And now we do something that's, I think is pretty cool, is we say this is just equal to dgt of the group y times e to the t squared over 4. And that still equals this side. And then we note that to get rid of this d dt on each side, we can just integrate with respect to d dt. Okay, so after we slap on the integral of each side, we note that this side becomes y e to the t squared over 4. And this side is actually a special integral known as the Gaussian integral, which is known to not have a general analytical solution representation. So in order to solve for this, we actually just keep this in terms of the integral. So we say y as a function of t is equal to integral e to the t squared over 4 divided by e to the t squared over 4. Alright, so that's all I have for you guys today for this really brief introduction to differential equations. I know this is kind of a simplistic introduction. I'll be getting into kind of more fun and interesting problems later in this series, so stay tuned. Remember to like, share, and subscribe. I guess that's what YouTube people say.